And I'm very excited to have John Resig here today. He lives in Boston, but works for Mozilla. So every once in a while he's out here, and I asked him a few months ago to let me know when he was coming out so we could get him to come to Google and do a tech talk. For people who don't know, John is the creator of jQuery. He works at Mozilla as a JavaScript evangelist. He's an author. He wrote Pro JavaScript Techniques, and now he's working on Secrets of the JavaScript Ninja. And every once in a while I get these basking in the warm glow moments at conferences because I'm surrounded by people like John who are at the forefront of web development today. And you can really see how much they're personally putting into the work that they do. And so in addition to his work with Mozilla and Firefox and jQuery, John also works on Firebug, is pretty much leading the Mozilla contributions to Firebug. I think is FireUnit released? FireUnit just came out. And so we're all in good hands with people like John in the lead. So John, I wanted to present you with this bag of Google goodies.
Well, thank you.
Okay, and then I'll take that away from you so you don't have to hold it. And without any further ado, please help me welcome John Resig.
So I want to thank you all for coming out today. I really appreciate it. So I wanted to talk about a couple things today. Specifically, I wanted to talk about pretty much all the new things that are coming in browsers, in the latest releases of browsers. And I wanted to look at all the performance improvements, especially related to JavaScript and the DOM, and all the new APIs that are starting to land, trickle down from like HTML5 and the new W3C specs. So a lot of my time lately, at least at Mozilla, has been spent working on this performance suite called Dromeo. And this is a test suite for doing performance analysis on JavaScript and DOM within a browser. And doing this has really opened my eyes to the issues that browser developers and implementers face when they deal with all these minutia in these APIs. So I find it to be really interesting. So I wanted to talk about some of the upcoming browsers here that are on their way out and should be hitting the streets here relatively soon. So there's Firefox 3.1 is coming out here in just a little bit, and Safari 4, IE8, Opera 10, and then the next release of Chrome. But the big thing that is common amongst all these browsers is that they are all actively iterating and rapidly improving their performance. And this is really huge, and it's really exciting. It's a great time to be developing. So I wanted to just quickly jot through some of the new big things that are going to be in these browsers coming up. And as I talk about some of these APIs, please, if you have a question, raise your hand so we can cover it a little bit more in depth. But so Firefox 3.1, it's currently scheduled to be coming out here pretty soon. Beta 3 is going to be coming out, I think, within just the next couple weeks. And but a lot of the big things is that it's going to be much, much faster for Firefox 3. There's a whole new JavaScript engine landing. There's the new video and audio tags, which has been in the news recently, and private browsing. Private browsing is another feature that's sort of just all browsers are implementing it pretty much simultaneously now. Safari 4. The actual release date isn't quite public yet, but it's pretty much assumed that it's going to be coming out whenever 10.6 comes out. The big things are that it's going to be completely ASA 3 compliant. It's going to be much, much faster, even faster than before. And it's going to have this new concept of being able to deploy web applications to your desktop. You can, I showed you a little menu up here where you can now do save as web application. You can take a web page and save it to your desktop and then load it up again in sort of a quasi-offline mode. A lot of this is going to be made possible by the new HTML5 offline portion of the specification, and that's really great in and of itself. IE8 is this one's also coming out here really soon. They just released the new release candidate, but even while the performance of IE8 doesn't really let's say compare to what's happening in Firefox and Chrome and WebKit, it's dramatically faster than their previous release of IE7. And at the same time, they are now doing what's called process per tab, and this in Chrome as well. But the concept that each individual tab is running in a separate process rather than in a thread, like what happens in Firefox and WebKit or Safari. Yes. Okay, so the question was, when Steve looked at it, it looked like it was two processes, one for Chrome, one for all tabs. I'm not sure exactly, at least from what Microsoft has said, that they were splitting it up. Maybe by splitting up was only splitting twice. I know at least within the case of Chrome, it's definitely split per tab. So I would not be surprised it's only split twice. Opera 10, the release date for Opera 10 isn't solid yet. They haven't made any big announcements. A beta just came out recently. Another big, they are as well are shooting for full ASA 3 compliance and video and audio tag amongst some other APIs, and hopefully a new UI skin as well. And then Google Chrome. I'm sure everyone here is well familiar with it. But the new release here should be coming out relatively soon. But the big thing that it really popularized was this process per tab, and this has really helped to change how developers are able to look at web applications. Because right now, browsers generally they have everything in just a single process. Everything, each tab is split up amongst multiple threads, and they're all handling different things. One might be handling rendering or doing networking, and the problem with that is there's a tendency for a lot of collision to occur. And if one tab is slowing down, consuming a lot of resources, one page is consuming a lot of resources, your other tabs will be blocked. So with this new process per tab model, you start to confine everything extremely. So what you end up having to do is you sacrifice memory for the benefit of performance. So at the very least, it's resulting in some. You can run some really heavy-duty web applications without interfering with whatever else is going on. One thing that I really liked about Chrome, though, was the fact that you could monitor each individual tab and see how much memory and resources each tab was consuming. They included this view. It's almost like a Windows Task Manager, but within Chrome itself, and that was very eye-opening, because most of web developers have no idea how much their websites are actually affecting the outside world. They have no idea if their website's consuming 40 megabytes of RAM or 140. And it's really important to know that if you want to do something, a web application that is actually going to be deployed widely. A couple of the other changes that happened here with Chrome, and they changed it such that timers can now run at rates faster than normal. I know Mike Belshie is here, and he was responsible for this. But this is very interesting, because typically browsers have a floor for how quickly a timer can run. It's usually around 13 milliseconds or so, how quickly it can be called over and over again. What that means is that it's limiting the number of times, let's say, your frame rate for an animation, or number of times to query a particular object, or what have you. But what happened is that now that they've moved into a process per tab model, you can now give a tab the ability to just check as frequently as it needs to, or update the page as frequently as it needs to, and without fear of it blocking the resources of the other tabs. So this is really nice because now you can get insanely high frame rates in Chrome, for example, where you can just do animations at many hundreds of frames per second, which is really quite exciting. So I wanted to talk a little bit about the new JavaScript engines. So there's 3 new JavaScript engines that are coming out here in or are in various stages of release in WebKit, Safari, and Firefox, and in Chrome. And so Firefox has, well, I should say that all of them are competing very, very heavily at this point. But this is really fantastic, in my opinion, because when these browser vendors all compete and all try to one-up each other and for performance, the end result is that users just get a better experience. The users, the pages load faster. Developers, their applications will run faster. Everyone wins. So it's really great, and I hope they keep battling it out indefinitely. But all these engines have a couple common features. At this point, they all have virtual machines of some sort, so that they can run some sort of optimized bytecode representation of the JavaScript. And additionally, they also, almost all at this point, do some sort of shaping. So looking at objects to determine their general feel and structure, and being able to do things based upon that. So here's just a sort of rough structure of how the engines currently break down. I mean, when you write your JavaScript code, you end up it ends up going through multiple steps before finally and eventually executing. But the result is that when these engines are breaking down into this lower, bytecode layer, they're able to optimize their engines much more dramatically and make tweaks that just unleash performance. I wanted to talk about this a little bit because just to give an example here, in just my pseudo bytecode, this is not 100% accurate, just to give you an idea. So like if you have a very simple operation, adding 2 variables together. The problem is that in JavaScript there is a lot of ambiguity. When you add 2 variables together, you may be concatenating them. If one of them is a string, or if they're numbers, if they're both numbers, then you'll be adding them. So, and you need to like underneath the hood, all of these options are, all these checks are occurring. It's checking if each variable is a string, and if so, concatenating them together. If it's neither of them a string, then it's going to add them together. And then within each, concat and add, there's a whole other set of options that have to be executed. But the nice thing is that they're starting to do some optimization here. So what's roughly called shaping, so that they can determine if an object is if it looks like a string, and if it probably is a string, then make some assumptions and remove some of these checks. So like even here, so like if we were trying to get the method property of an object, there are a huge number of checks that have to be done simply before we can even get the property, and that's even before actually executing it. But if we do some sort of shaping, all of this code ends up boiling down to a simple, couple pieces of bytecode operation, rather than dozens and dozens of execution, just to access a single property. So all of this optimization is dramatically improving the performance of web pages and on test suites. So I just wanted to talk about a little bit about some of the engines in particular. There is TraceMonkey. This is the new engine released by Mozilla, replacing the old engine SpiderMonkey. It's a variation of SpiderMonkey, and this one uses what's called tracing technology to optimize commonly repeating patterns, like, things that happen again and again. So, for example, if you had some loop that was iterating 1,000 times, and it was calling some function within that loop, what it might do is remove some of the costly bytecode checks that need to occur. And that making sure that for example, the letter, the variable I, it's probably going to continue to be a number throughout the lifespan of this loop. So removing just making assumptions, assuming that I is going to remain a number, that optimizing, adding one to the variable I, all of these things. And so that when these loops start to occur and when it starts to go through and iterate back and forth, it can start to remove that and optimize it down, especially with inlining some of the function calls. So taking these external functions, pulling the code out of them, and essentially inlining them into a single block. So that way it ends up being just so much faster. An empty loop, I remember seeing some numbers for that an empty loop running in TraceMonkey was comparable to the speed of the empty loop running in C. Of course, that means pretty much nothing since you're just doing an empty loop. But the important part here is that it's trying to strip away as much extraneous stuff as possible, which is really good. So Squirrelfish, the WebKit team did all sorts of work to get good just-in-time compilation working for their JavaScript engine. And they did a lot of work on their bytecode and optimizing their bytecode. And you can especially see this in the performance on regular expressions. The regular expression performance is pretty much insane, and they basically did all sorts of optimization there and making that fast. And then Chrome V8, in their engine, they did a lot of work in doing more shaping, which I talked about earlier. But that allowed them to do just really fast property lookups on objects. And it's really quite impressive when it was released. So there's a lot of difficulty in trying to get an accurate measure of performance, trying to understand what exactly makes a piece of JavaScript code accurate and representative of JavaScript code as a whole, and especially so, does optimizing for this piece of code, will it actually help users? So there are a couple test suites right now, each released by the different vendors, and there's the SunSpider test suite released by WebKit that includes a number of different tests for testing pure JavaScript. The V8 benchmark, which is released at the same time as V8, that also includes a number of pure JavaScript tests. Then the Dromeo test that I wrote and released. And this one contains a mix of JavaScript tests and DOM tests, and it actually includes both the SunSpider and V8 benchmarks as well. Just to show some numbers, these are outdated at this point. I don't think it would be possible to give you numbers that were even up to date, since everything changes every single night. But the important part here is that the performance of old browsers used to be like IE7 level of performance, and like I mean, if you look at the difference between these couple browsers on the left, it's minuscule in comparison. I think these numbers are actually a couple months out of date at this point. But I mean, everything has just gotten so dramatically faster in the last couple months, even, that it's really just blowing away. So this is on the Chrome benchmark. It's not completely clear if the Chrome guys just happen to be really, really good at their benchmark, or if they optimize for the benchmark. But regardless, they do really good on their benchmark. And then on Dromeo as well. And this one, again, this one tests the mixture of JavaScript and DOM. All right, so I wanted to talk about some of the new improvements that are coming outside of JavaScript engines in particular. Steve Souders released, sitting right there, released an excellent tool for helping browser developers determine what exactly is going on at the for loading items over the network in browsers. and it's his UA tool. I provide the URL there. But this is a rough breakdown of the number of features. He breaks it down into a number of different categories, which I'll go into here in a second, and shows how well each browser passes that. For example, for simultaneous connections, so meaning that if you have a number of images in your page, how many images can be downloaded simultaneously. So the higher that number is, theoretically, the faster a page is going to be able to load. And you can see the steps in improvement here. So older browsers, Firefox 2, IE6, IE7, they all have a maximum connection number of 2. But as browsers, start to increase here, you see it goes up to 4 in Safari, and then other browsers, Firefox 3 and Opera, all have 6 to 7 connections, simultaneous connections. And I should say simultaneous connections per domain. A maximum number of connections is so that if you have images being loaded from multiple domains, how many can you be doing at a time? And that's really high. So we're talking anywhere from 25 to 60 simultaneous connections. Another big thing is being able to download scripts in parallel, so that if you have 2 scripts on a page and they both take 200 milliseconds to download over the network, that it won't take 400 seconds total. Instead, it will just take 200 milliseconds since they downloaded this simultaneously, and then execute back to back. There's another thing that's starting to be implemented more widely. It's called the defer script, and this is actually going to be in Firefox 3.1. It's in Internet Explorer, and it's also in Opera. And it allows you to say that given this script, to load it asynchronously, and then execute it again at a later time. It doesn't matter when this script executes. But additionally, there's some properties of a deferred script, like it can still document write, and when the document writes, it still does it in the correct location in the document, things like that. So, but when browsers start to implement this, you're going to be able to put this defer script on things like ads, and the ads will be loaded, will be deferred loaded, and then injected into the document, when they're finished loading, as opposed to blocking the entire document load. Another big thing that browsers are getting better at is redirect caching. So every time you access a website, if redirects occur from adding in slashes or going to a different document page, this can it adds up. It's another network request. And some browsers are getting better at this, like Chrome and Firefox. They're caching these redirects so they don't have to be done over and over again. It seems really tiny, but it's little things like this that really add up. And optimizing these and fixing them can really improve the performance of a web application. So this is a nice new thing. It's called link prefetching, and it allows you to preload resources on your site, so that you can say, that at some point later on, I'm going to use this image. You're telling the browser that load this ahead of time, so that the user doesn't have to watch it, load whenever it pops in. So this is something relatively new, and right now it's only implemented in Firefox, but it's generally a much better way of managing this, as opposed to having to go through JavaScript and using JavaScript to manage all this downloading and prefetching in the background. All right. Any questions before I keep going on? Yes.
Actually, on the direction of the JavaScript runtime performance, how has JavaScript parse time increased over time?
So the question was, how is the performance of JavaScript parse time increased? So right now, the test suites, I should say, so out of the different test suites, currently only SunSpider tests parse time, but they don't test it separate from actual execution time. It's all clumped together. So it's currently no suite analyzes just parse time versus the total execution time. That is absolutely something that should be analyzed, since that affects the initial load. You want to make sure that when that first hit occurs, you have 200K of JavaScript that gets parsed really fast. So it's not completely clear what the best ways of analyzing that are, simply because it's not something that can be easily done in a browser context. You might have to move to a command line context, and at that point, if you're measuring on the command line, is that really a realistic test since you're not in a browser anymore? There's a lot of questions, but I agree there's not a good test there yet. Yes.
Sort of related to that, does the jitting of the code slow down that initial execution, and are they able to then cache those jits so that next time you come back to the page, it hasn't gone out of cache or whatever, it doesn't have to rejit it?
So repeat. So is this jitting? Does it slow down this initial load? And is this cached? So at least in my experience, looking at the numbers, the jitting does not significantly slow down performance. At least not in a way that the browser vendor is concerned about, because it ultimately wins much more later on. But as far as caching, as I understand it, most cache within a page, but not from page to page. If once you leave a page, you're pretty much done. It depends how much sharing of a execution context there is. Simply because I guess that might be a case where a threaded environment might work better, since they all know what's going on with the other processes.
Also, like if you're including jQuery off of CDN, a whole bunch of pages know that's the same jQuery point whatever that I've used. You think you do that once, and then everybody else uses it?
Yeah, so that's another question is, if you're pulling in something that's obviously an identical piece of code every single time, jQuery or Dojo, YUI, it's if there was a way to send down a straight bytecode, to say, hey, here's the lowest level you can get, but at the same time that would require that all the browsers standardize in a single bytecode, and they're having a hard enough time standardizing on just JavaScript. So I mean, we'll see. Yep.
So back to that earlier question about parse time, can you just throw out a rough estimate, for 100K uncompressed JavaScript, is that typically on the order of single milliseconds, tens, hundreds?
I couldn't say. I wouldn't feel comfortable giving a good estimate until I had good data. I mean, at least this parse time is, at least for right now, at best, it's just clumped in with execution time.
So a related question, so suppose it is, we found that scripts download time takes a long time. So developers and browser vendors have worked to address that, because we can measure that more easily and see how these improvements improve latency. So suppose we do find that parse time is hundreds of milliseconds. Do you think that there are tactics that developers or browser vendors could do that could fix that very much?
So the question was, if it's found out that parse time is a significant burden, that's something that should be optimized. I assume that if solid numbers come out for all the major JavaScript engines, you better believe that the browsers are going to be working to optimize that number. For developers, I'm not sure. I mean, and again, that's another case where better tooling would help, to answer those questions. Yes.
Could you repeat the question for the remote sites?
Yeah, when he's done. Okay, so just to repeat, so the vast at this point with the new engines, the vast majority of time isn't spent parsing. In fact, very little time is spent parsing, and that these new engines are trying to be as just fundamentally lazy as possible to try and break parsing out later and worry about everything later. And so, I mean, there may be an initial hit, but it definitely isn't a massive hit, at least not in comparison to old engines. So just that yeah, right. So the initial parsing and in chatting isn't free, but the ultimate win you get is pretty awesome. So okay, any other questions? All right. All right. So I want to talk a little bit about the communication layer, some new communication APIs that are landing. One of the ones that's actually being implemented quite widely is post message. This method allows you to, it exists on Windows, and allows you to communicate from one window to another. So like from a page to an iframe, iframe to a parent page, from things of that nature. But what's so good about it is that it works cross-domain. It doesn't matter if the frames are owned by different domains. So for example, if you had an iframe in your page, you could send it a text message, test or what have you, and a URL. The URL specifies, you're saying, send this message to this iframe only if it matches this URL. The iframe then would then listen for messages that get passed into it from post message. And so it listens for a message event, and then verifies the origin of the incoming message. Makes sure that the message is coming from a domain that it trusts. And if not, just stops doing whatever it was going to do, but otherwise, uses the data that's coming in. So using post message, you can implement all sorts of interesting things. In some personal experiments of mine, I've used post message to implement a cross-domain XML HTTP request, because you just insert a little iframe and you start doing communication back and forth, and it becomes very usable. So this is I think a very interesting new API. There's true cross-domain XML HTTP request. This is using the W3C access control API. And if on what you do is you use XML HTTP requests as normal, and you would try to request a remote document. It verifies if certain headers are in place that will allow this a piece of XML, HTML, what have you, to be requested. So in the case of the access control, you can specify, for example, access control allow origin, and then you can specify a single URL. So say only allow things that come from Google, only allow requests that come from Google, or in this case, star, allow requests that come from everywhere. And you can really filter down this way. So what's interesting is that this new access control specification is starting to be used like everywhere within the specifications and within HTML5, and it's very likely that, or there's still a lot of debate, I should say, over whether or not this should be specified for like audio and video tags, so that if you want to include a remote video, that does it have to have these headers to allow you to access that video? It's not really clear at this point. So yeah, this is the response header, correct? So in this case, if you had an HTML page on a remote domain, and you tagged on that extra header, you would be able to any browser that supported this cross-domain XHR would be able to request it. There's some decent improvements coming in DOM navigation. One of the early ones to land was get elements by class name, allowing you to find all sorts of, find elements on a page that have a specified class. This is in some current browsers, Safari 3, 1, Firefox 3, and Opera 9.6. We just found a bug just the other day in Opera's implementation. It's unable to find, actually this example here doesn't work in Opera 9.6. It's not able to find the second class and a class name for whatever reason. It can only find the first one. So yeah, it's still a work in progress. But at the very least, it's very fast. It's way faster. Just to show you. So like on the left, on the right here, we have some old school methods, just pure JavaScript DOM. We have an XPath implementation, but then there's the native get elements for class name, and it's a tiny fraction of the normal cost. And so because of that, JavaScript frameworks that take advantage of it are instantly sped up, and using it in your code is it's a huge win. One of the things I'm really excited about now is the new selectors API. This is the W3C specification, selectors API specification, and it gives you new methods for finding elements on a page using CSS selectors. And so it's good because you get the best of both worlds. You get an intuitive syntax. Developers are already familiar with CSS rules, for how they match elements, and at the same time you get just crazy speed. But I'm really excited by the fact that everyone's implementing it. It's implemented in IE8, Opera 10. It's going to be in Firefox 3.1 and Safari 4. It's everywhere. I'm really excited by that. Just to show you some performance on the left here, we have some traditional JavaScript libraries that are just using regular, JavaScript query, JavaScript DOM. And then on the right is, query selector all, and it's a tenth. It's 10 times faster than the next closest library. Of course, all the libraries now are adopting query selector all, since it makes a ton of sense to. So that's going to be really great. One of the new ones, specifications that's just finishing up and starting to land in browsers is called the Traversal API. This is a W3C specification. It's implemented in Firefox 3.1, but it gives you a couple methods that you can use to make navigating around a DOM document easier. Roughly, it makes it so that you can access element siblings, and because traditionally there's if you access first child or last child or what have you, you could get a comment node, you could get a text node, you could get any number of these things, and when a lot of the time developers just want to get the elements that are there, since that's usually what's visible. So those four things are in the specification. They just landed in Firefox 3.1. But one of the things that's unrelated to that specification is .children. This was something that was originally in Internet Explorer, but it is now implemented in every browser. Every browser now implements it and allows you to get only the child elements of a parent element. And so in a lot of ways, having .children around kind of removes the need for this new specification. But the nice thing is that in Firefox 3.1, they actually implement .children, so now it'll be absolutely everywhere. All right, so drag and drop. There's some browsers are actually starting to implement the HTML5 style of drag and drop. There's you get all sorts of messages to indicate events to indicate when dragging is occurring, starting and stopping, and you can hook into this and transfer data from different points in the document. It's pretty cool, and something that really should have been done a long time ago. So we're starting to see this now start to land in browsers. But in the meantime, we're kind of stuck since not everyone implements it yet. But in the meantime, we can use get bounding client rect. This is a method that is starting to get implemented more. This is an Internet Explorer method historically, and it's starting to get implemented more in more browsers. And what it allows you to do is it allows you to find, get a pretty accurate representation of the position of an element in a document. And when you're doing drag and drop, you need to determine pretty accurately where that element is currently located so that you can move it accurately and so that you can position it well. And so this is, it's really fast and it's starting to get implemented more, which is awesome. Another great thing that's, that I'm really excited about is the inclusion of threading in JavaScript. This is just starting to come out here, and it's really, really exciting to see this land. So what it's called is called a web workers, and it's not threading in the true sense. But what you can do is you can spawn scripts that can run in the background, and you can communicate with them using message passing. So just to show you a simple example, here we have a script being loaded in externally. So in this case, it loads in the myWorker script file and executes it in the background. And then at the same time, whenever the worker is done executing, a message will get passed back to the onMessage callback, so that you can start to communicate back and forth with these scripts that are getting loaded in these workers. Just wanted to show an example. So this is done by Oliver Hunt. He's on the WebKit Squirrelfish team, and he built a ray tracer in JavaScript. So I'm just going to disable this. So right now it's using the canvas element to draw. If we run this, we can see it truck along. So this is just regular JavaScript communicating with Canvas, doing all the calculation and drawing everything out. It takes a while. It is even in this right here. This is Safari Nightly. I mean, it's still going to take, I'd say, about 15-20 seconds to run. So once that finishes, okay, 27 seconds. All right, so let's reload and let's add in a couple worker threads. So what that's going to do is going to break apart different portions of the image to render, send it to each of the workers, and then when they're done, it'll report back and draw them. So let's run this now. There we go. Now all the worker threads ended it in 3.5 seconds, so almost 10 times faster. And that was with only 4 worker threads. We could probably up that a little bit. Figure out a sweet spot. Say what? I don't know. He's asking, is it because of a set timeout or something? Not sure. I'm not sure what I was talking with him before about his implementation, about why well, I guess we could go down to 1 worker thread. Well, we can't really see it. That's not exciting. Hang on. So yeah, my guess, maybe just the other implementation he had was just bad, maybe. But so even so, using 1 worker thread, it took 6.5 seconds. 4 worker threads was able to speed it up to 3.5. So I mean, there's a definite room for speed up. Unfortunately, there are a lot of gotchas with this new worker thread stuff. One of which is that when you pass messages to one of these workers, it has to be as a string. A nice thing, though, is I'm glad they started to do this, that if you pass in a JavaScript object, it'll serialize it as JSON and then deserialize it again. So the important thing here is that they wanted to make sure that there could be no information leak, no access to external windows or anything that an inner thread shouldn't have access to. And additionally, these inner threads have a really limited existence, let's say. They only have access to basic JavaScript. They don't have access to the DOM. They don't have access to Canvas. They don't have access to any of this stuff. So in the case of these threads here, what's really happening is they're probably just pushing around matrices of numbers. And then the main thread, the one in the window, is just is the one that's actually doing the rendering to the canvas. So I definitely hope that at some point we'll be able to pass around canvas objects, and pass a canvas object to a thread, a worker, and then have it come back with some results. That'd be really awesome. Any questions on the worker thread stuff, really quick? All right. Okay, so there are a lot of different, CSS-related things that have started to get implemented, and these are different just stylings and effects you can apply to your site. But while they don't provide an immediate, obvious JavaScript-y performance boost, what they do is they allow you to dramatically simplify your markup and remove all sorts of cruft that you won't have to deal with anymore. One of the popular ones is one of the ones that was implemented really early was the ability to do rounded corners. Traditionally, in order to do rounded corners, either required loading in extra images to represent the corners, or doing all sorts of really nasty hacks with lots of little divs being spaced around. And in either way, the old methods were not good. But with the new CSS properties, you can just add in corners as part of a style sheet. There's also the concept of shadows. Both having shadows on text, so a drop shadow, but being able to have shadows around arbitrary elements. So, if you have a div that's supposed to be hovering somewhere on the page, you can actually put a drop shadow behind it now and give that extra appearance. And this is implemented both in WebKit and Firefox. Let's see, I'll jump back to the examples here real quick. But there's also the ability to load in custom fonts. So right now, most solutions for loading in fonts are usually Flash-based, like there's a Cipher and other ones of that nature, and they load in a font file and render it in a Flash context. But what's starting to happen is actually getting some good custom font support in CSS. Let me see. Oh, and then before I jump to the demo, there's also new transformations and animations starting to land. So WebKit has been really pushing forward here, starting to land all sorts of new ways to do animations from CSS, so no JavaScript involved whatsoever. And it's really quite exciting. So let me show some of these demos here. This is an example of the box shadow. So these are just normal little divs. You can resize it, and the shadows persist. And these are all just styled with this box shadow property. Here we have text shadow. So this guy made a hilarious demo page of things that you should not do with text shadow. And so he animated the text shadows, and so added a fire style. I like that one. And he showed all sorts of ways. Using shadows, you can get things that look like they've been embossed or things of that nature. There's also the concept of transformations. So in this case, these are set to animate when I move my mouse over and then start to transform an element. So you transform by position. This is all CSS. There's no JavaScript. Rotate, grow in size, and then you can also combine properties. So in this case, it's actually animating rounded corners, color, and size all at the same time. So it can get pretty exciting. I'm sure that'll be abused in many, many ways. And then here's an example using a custom loaded fonts. So you can see this is actual real text here, and it's all being styled using true type fonts that were dynamically loaded in. Let me see if I can hard reload here so you can see the. Oh yeah, so it just gets all pulled in there. Okay. One of the things that I've been most excited about lately that's been getting really good support in browsers has been the new HTML5 canvas element. And this new element essentially gives you a 2D just box in which you can draw arbitrary shapes and pixels and what have you. But it gives you a ton of power to be able to actually draw on a web page. And the things that people have been doing with it are really quite fantastic. There's also a library that was produced here at Google called XCanvas that allows you to use Canvas in other browsers. Use Canvas in browsers that don't support it, like Internet Explorer. Unfortunately, it doesn't support some of the new APIs, like being able to work with matrices of pixels and things of that nature. I wanted to show a quick demo. I released early last year I ported the processing visualization language it's a Java language implemented in Java and allows you to do all sorts of visualizations. I ported it to JavaScript running inside of Canvas. I wanted to show some examples here. This is a simple one. So this is just doing it's basic collision detection and multiple objects being rendered. It's all in real time in a Canvas element, using JavaScript. Let's see here. So this one is actually, it's scanning the pixels of an image and rendering out it's going by pixel through an image that's loaded into a canvas and drawing out the pixels of it. Let's see. And you can actually see where exactly in the image it's currently pulling from. Let's see here. I like this one. This is a flock of birds. So you can really start to see the performance of these JavaScript engines. So it's doing all the computation to figure out how the birds should be flocking together and then rendering them simultaneously to the canvas. I like this one too. This is sort of a blobby shape that you can play around with. Yeah, I just have way too much fun with this stuff. But I love Canvas. I think it's definitely one of the best things to come out in web development as a whole. Just showing some examples of what things you can do with Canvas. It gives you the important thing to realize is that Canvas is not SVG. You're not dealing with vectors, and you can't mutate shapes once you draw them. Everything you can think of it like Microsoft Paint. You put it down, it's there. And the only way to get rid of it is to draw on top of it. So you're constantly just, you have some basic primitives. You can draw rectangles and circles and things of that nature. And then when you draw, you're given a series of fills and strokes. So you can fill a rectangle with a color, set a stroke on the outline, things like that. Yes. Yep. Okay. So the thing that's nice about Canvas, though, is that it behaves just like a normal HTML element. You can embed it straight in line. It handles z-index properly, opacity. It behaves completely normal. So I've seen cases where people have used canvases to do things like drop shadows or rounded corners. For browsers that don't have them, being able to draw custom backgrounds and all sorts of things dynamically. I've even seen cases where someone has drawn custom UI widgets using Canvas elements. There's really a lot of possibilities. Canvases themselves can consume images, so you can port an image into a canvas. And additionally, in Firefox 3 and Safari 4, which have the video element, you'll be able to take a frame of a video and put it in a canvas element and manipulate it. So that'll be pretty exciting. One of the things that's also seeing a lot of play is the ability to have better control over data on the client side. And one of the big things has been the introduction of some sort of SQL storage on the client side. And this was introduced in HTML5, and it was implemented in WebKit. It gives you a full database, so you can create a database for a website and then run SQL queries against it. It's actually just a SQLite implementation running in the background. wanted to show an example. Just the other day, Brandon Aaron, contributor to jQuery, he wrote a little API browser. This is actually for the iPhone, but so you can browse through the API and you can view methods and whatnot. But all of this information was actually loaded up in the background, and it was actually stored in a database. So if you look here, and this is in the console, you can see the database, and here's, let's see, here we go. Yeah, I mean it's just a SQL database. So I mean, and you can go through and see everything that's powering the website. Additionally, this actually works on the iPhone as well. So in this case, when you first loaded the application on the iPhone, it would download all the data, store it in a SQL database on the iPhone, so that it would be able to load faster in the future. And then also there's the native JSON support is starting to land in JavaScript engines. So this is giving you the ability to parse JSON and be able to convert JSON or a JavaScript object to a string in just very, very quickly. Just want to show you the performance breakdown. The yellow and purple lines are traditional types of parsing JSON. I should say encoding and then decoding, and the red line, with the one that has virtually no spike to it, is the native one. So it's dramatically faster. It's really quite excellent. So I think I'm running out of time, so I just want to quickly open up for questions at this point, if anyone has any questions about what I talked about today. Yep.
So earlier on you talked about the optimizations that can be performed by analyzing the code by analyzing JavaScript code. Do you think that there is part of the problem that arises when you are trying to analyze this code is that JavaScript makes it really difficult to do the analysis required in order to optimize sections. Now, ECMAScript 3.1 has modes like strict, which make it, amongst other things, easier to analyze. Do you think that there is reasons for libraries to adopt a strict mode that makes it easier for interpreters and browsers to optimize the code that is being to optimize the bytecode that is being generated?
So the question was, does it make sense to provide a strict mode that will make it easier for interpreters to analyze, especially in the context of JavaScript libraries? I'm not completely sold on it. I mean, the whole reason for like a lot of the old ECMAScript 4 stuff was that there was a huge assumption that you weren't going to be able to make JavaScript fast, because JavaScript was, it's a weird language. It isn't statically typed. And because of those, and so they added things like classes and types and all sorts of things. And then they found out that, hey, we can make JavaScript fast. In fact, we can make JavaScript really fast. So I'm not really sold on there being restrictions to the language, especially since current browsers seem to be doing just fine anyway. I think it'll only just limit what you can do. Yeah. Another question? Yeah.
It seems like, especially for me, that the focus on performance amongst the development community has gotten way further ahead of the tools that are available to do that kind of analysis. As someone steering Firebug and knowledgeable about other stuff that's out there, do you have any bright light at the end of the tunnel you can tell us about?
So he was saying that that the performance is getting much faster, but the tools that we have for understanding it just aren't there yet. What's available? So I mean, it's incredibly difficult at this moment. I think one of the big things going forward is that we have to be able to give developers more information about, to start, how much CPU and memory their sites are using in all browsers, not just Chrome or whatever browsers are particularly blessed. I would say it's much more important that browsers that leak memory badly, and so being able to have good tools there so that we can better understand how to write, let's just say, acceptable web applications, right, we'll be able to, I think, expand a lot better from there. Yeah.
How aggressively are web developers going to be able to take advantage of all these new capabilities since we still have this tail of legacy? Like, either how long will we have to wait, or are there ways people are deciding, we're going to start not supporting these other browsers or other kinds? I mean, otherwise it's very tantalizing, but like, can a mainstream site really use this stuff in the next while?
So your question is, how much can a site really start using these? So the ones that I picked today are all ones that can be used in some context. I mean, obviously, it isn't an all or nothing situation. So, for example, the worker thread, the web workers, you can write one that works now. It draws very slowly, but it draws. Or it's literally just a drop in, and you could just start to use threads and get a better performance. And so I think there's a lot of cases, workers, get elements by class name, being able to do, the query selector all that stuff. Not only does it make your stuff faster in a very simple way, but since it's just JavaScript, you can just detect to see if it exists. And if it exists, do your fast thing. If not, do your slow thing. So I think there's absolutely room for being able to do all this now. And I think it's really important for developers to be able to start to do that. Because if they're able to show that newer browsers not only are faster, but just light years ahead in performance, they'll be able to get users of IE6 and older browsers to be able to move and upgrade. So I think that's all the time we have. I'll be around for a little bit, so if you have any questions, feel free to ask. So thanks for having me.
Thank you very much, John. Secrets of the JavaScript Ninja. When do you think it'll be out?
This year, let's say.
Okay. Thank you very much.